Hello guys, welcome to my YouTube channel. So today we are going to discuss one of the most important questions which came in GATE 2023 BT paper. So this was on bioprocess engineering, and most importantly this topic is on cell culture in chemostat with a recycle. So it is basically chemostat with a recycle model. So if you have like watched my previous lecture, I have discussed chemostat with recycle, the detailed theory on it. So if you haven't, I encourage you to see my the video and then you proceed with this solution, because it will help to you to understand better. So we'll first read the question. The following schematic diagram shows a chemostat with a cell recycle where F0 and Fr are the volumetric flow rates in liters per hour of feed and recycle streams respectively. So what is F0? F0 is the flow rate of the feed stream and Fr is the flow rate of the recycle stream. So if you observe carefully in the figure, this is the F0. Okay, the flow rate of the feed stream which is entering, and this is the Fr, the flow rate of the recycle stream which is getting recycled from the cell separator into the chemostat. And x1, x0 and x are the cell concentrations in grams per liter. So in this problem units are also very important. So x1, x0 and x, what are these quantities? These are cell concentrations. So as you can see here from the figure, this x, this is the final cell concentration after the chemical reaction. So after what is coming out from the cell separator, this is the x, this is the biomass concentration, and x1 is what is coming out from the chemostat but is entering within the cell separator. Okay, so this is in between the chemostat and the cell separator, and x0 is what is in the recycle stream. So it is getting recycled back into the chemostat from the cell separator. So these are three different concentrations of biomass present in three different streams, and these units are grams per liter. You have another condition given, which is x0 by x1, which is 1.5, and fr by f0 is 0.7, and it has been said that x1 is 7.3 grams per liter. So you need to find the value of x. So your desired answer is this x. What will be this x? Okay, so first proceeding with this problem, you need to know the basics of chemostat with recycle. That means the theory part, how we do mass balance and everything. That is why I told you to observe my lecture and then you see the solution. But anyways, I'll just give you a quick recap. So this x0 by x1 which has been defined, this quantity is denoted by C. Okay, so this is called as the concentration factor. So it is defined as the amount of biomass or the concentration of biomass present in the recycle stream divided by the concentration of biomass present in the exit stream. So this is called as the concentration factor. Okay, so x0 stands for the biomass concentration in the recycle stream, and x1 is the biomass concentration in the exit stream, and this alpha is what is they have given, which is fr by f0. This is called as recycle ratio. So this is defined as the flow rate of the recycle stream divided by the flow rate of the feed stream. Okay, so this is called as the recycle ratio. So you need to know two important quantities, terminologies of two important quantities. So this condition what they have given, this x0 by x1 is actually they have given the concentration factor, and this fr by f0 what they have given, this is actually the recycle ratio. Now what we have to do, we have to do mass balance around this cell separator. Why mass balance around this cell separator? Because we need to find the value of x, and x is getting generated from this cell separator only. So first we have told you that this concentration factor C is actually x0 by x1. So from here by transposition we can write it as x0 is equal to C of x1. So this is very important. This we will utilize later. Another thing, the recycle ratio is written as Fr by F naught. So by transposition, we can write it as Fr is equal to alpha F naught. Okay. Now we apply the rules of mass balance. So rule of mass balance says rate of mass in is equal to rate of mass out. So rate means mass per unit time. So this is actually denoted as m by t or dm dt. So what should be its unit? Mass balance. The mass balance has unit of grams per hour or grams per second, whatever. That means it has a unit of mass per unit time. Okay, so everything we will do mass balance with respect to grams per hour. Now I will like to tell you one important thing here. You have the flow rate. You have the flow rate which is given in liters per hour. Here, this is the volumetric flow rate. So it is volume per unit time. This is actually liters per hour. Okay. And you want the final unit to be in grams per hour because you need to do mass balance. So what should you multiply with liters per hour? To get grams per hour, you should multiply something grams per liter. Okay. So if you multiply something grams per liter with liters per hour, this flow rate quantity, you will get grams per hour, which is our desired. Now what is this grams per liter quantity? This is actually any cell concentration that you take. Any cell concentration. So here there are three different concentrations, x1, x0, xx, and they have mentioned that all the units of all the three cell concentrations and grams per liter. So accordingly we will multiply the cell concentrations with the corresponding flow rates to get the desired mass rate. Okay, so we do mass balance around this cell separator. So whatever is coming in the react cell separator is equal to whatever is going out from the cell separator. So this quantity is coming, so x1 is coming with a flow rate of f naught plus fr, and x is going with a flow rate of f naught, as well as x naught is going with a flow rate of fr. So what we can write, total rate of mass input is equal to total rate of mass output. So this is x1 into f naught plus fr. This is input. Okay, and f naught x and fr x naught, these two are output, and we are multiplying each cell concentration with the corresponding flow rate because we are doing mass balance. So we want the unit to be in mass per unit time. Now we have already figured out what is x naught. X naught is actually can be written as C of x1 in terms of concentration factor. So we will substitute this here. And what is fr? So fr is also, we have figured out, it is alpha f naught. So we will substitute it here, as well as we will substitute it here at these two places. Okay, because we want something with respect to x. So if we substitute it, then we can write it as x1 into f naught plus alpha f naught is equal to f naught x plus alpha f naught x naught. Now here, this term, from this term we can take one f naught common. So if we take one f naught common, it can be written as x1 f naught into 1 plus alpha is equal to f naught x plus alpha f naught c x1. Okay, so here we have got one x naught, we are substituting x naught, which is c of x1. Now as you can see here, this f naught, these f naughts will cancel, obviously, because there is the constant feed flow rate we are assuming. So we can cancel it out, feed flow rate of the input stream. So what we get finally is this thing, x1 1 plus alpha minus of alpha c x1 is equal to x. So this is the final relationship that we get. So we know x1, which has been already been given as c here, this is 7.3 grams per liter. We know alpha, it has been also been given. We know C, it has also been given, so we can find X. Okay, so if we substitute all the given values, we get the final cell concentration to be coming out from the cell separator to be 4.475 grams per liter, somewhat around this value. So the basic purpose was to, you have to do mass balance and you have to cancel everything, whichever is not given. See, if not, we can cancel, because if not, we are assuming that there is a constant feed flow rate inside the feed stream. Also, we are substituting Fr and X naught. Why? Because these values are not given. So we are substituting these values with respect to something which are given. So if we had kept these values Fr and X naught in our final equation, this equation, then calculation would have been a problem, because we don't know the values of Fr and X naught. So we are substituting Fr and X naught with some known values. Here in this case are alpha, C and X1. So we are finding out our final equation X with respect to our three known values X1, alpha and C, and then we are substituting all the given values and then calculating X.